So in this video, we are going to talk about drag. So we already talked about it a little bit, and we say that the drag is often due to the viscous and the pressure effects. So this is the drag, right? And this is the non-dimensionalized number that we are using for considering the effect of the drag. So we call that one coefficient of drag. So let me just write it down. So drag is often due to viscous and pressure effects, and also we can say that the drag coefficient is a function of shape, Reynolds Mach number, Freud number, and then the thickness. So this is what we have for the drag. And so if we are going to talk about the shape of the drag, so clearly the drag coefficient for an object depends on the shape of the drag, and we already talked about if the if for example we have a normal flat plate, or we have a parallel flat plate, so it's going to have a really different drag value on them. So for example, if we have, just let me draw it better here. So flat plate normal to flow. So if we have a flat plate like this, and let's say that this is the velocities, this is the length, this is the depth, this is the height of the plan. Or if we have the horizontal plate like this one here, then the frontal area for that one is the frontal area for this is B times D, and then the platform area is A equal to B times L. So this is D, this is L, right? And if we look at the coefficient of drag in this chart, so we can see that the flat plate parallel to flow, right? The value of drag, the coefficient of drag is here, and then for the flat plate normal to the flow, this is the chart that we are using, right? So this one, the dash one, is for the parallel to the flow, and then the solid line is for the normal to the flow, right? So this is what we have here, and then here we have it for the blunt objects. And we can say that the blunter the body, the larger the drag coefficient, and we can see that, right? Because if even if we want to use the flat plate normal to flow or the parallel one, this one right here, this is how they gonna get the drag coefficient, right? Even if we have the, let's say the blunt is here, it's also give you the higher value for the coefficient of the drag. And so another parameter is the Reynolds number. That drag coefficient can be varied, depends on the Reynolds number. So what we have here, so for the Reynolds number, for the Reynolds number is less than 1, the drag has the inverse relationship with the Reynolds number. For the range of 10 to the 3 and 10 to the 5, the drag is considered to be constant, the drag coefficient. And For this range of Reynolds number, the drag coefficient decreases and then increases. So first decreases and then increases. And again, for the last range of Reynolds number, the drag coefficient going to be constant. So now this is what I wanted to talk about the drag.